In this lesson, I will explain to you the concept of Gaussian normal distribution, which comes under the category of naive Bayes variance. And this is the third property of naive Bayes variance, Bernoulli distribution and multinomial distribution. We had discussed in our last lessons. Today, in this lesson, we will focus on Gaussian distribution, which is also known by normal distribution. So what is the meaning of normal distribution? Normal distribution means we can have the graph just like bell shaped, and the formula we will use, which is known by PDF. PDF means probability density function, right? F of x represents the random variable and its value lies between negative infinity to positive infinity. The question is, when we have to use Gaussian distribution or normal distribution, if the data set is available and the features are continuous in nature. If the features are discrete, as we had discussed in our last lesson, we have to use multinomial distribution. But if the features are continuous in nature, then we have to use the Gaussian distribution, right? Okay, so in Gaussian distribution, we have to find out the value of mu. See, mu in the formula is given, and you know very well, we had discussed so many times how to calculate the mean of the sample or the population. This is the population mean, and then sigma square is the variance of the population. If we take the square root of this variance, which is called the standard deviation, so this is the standard deviation, this is the variance. So we usually use these three items in Gaussian distribution, and you know pi is equal to the value of pi is 3.14 or 22 over 7, right? Okay, so here is the normal distribution. This is the normal distribution. It means in the bell shaped graph or bell shaped curve, we have same amount of data on the right hand side, same amount of data on the left hand side, and here this is our mu population. If we will go on the right hand side of the mu, this is called the mu plus 1 or mu plus 2 standard deviation, mu plus 3 standard deviation. Similarly, mu minus 1, mu minus 2, and mu minus 3, according to empirical formula, which we already had discussed, that our 68% data lies between mu minus 1 to mu plus 1. Similarly, 95% data lies here in the 2, and the 99, approximately 99% data lies between mu plus 3 and mu minus 1, right? So simple it is. If we have a continuous kind of data, we have to use the Gaussian distribution. Again, one important thing, that these you can extend on either direction, but these two will not touch on the x-axis. So this is the basic concept of the Gaussian distribution. I hope the concept is clear. Please practice it. See you in the next lesson, and thank you.